All right, let's go ahead and go over examples. Okay, once we set the denominator equal to 0, we solve, and x is equal to 3. That means my x-intercept, or my root, is at 3. So we're going to put a point at 3. Then we look for our asymptote. To find our asymptote, we look at the denominator now, which is x plus 2, and we set that equal to 0. So we subtract 2, and x is negative 2. So my vertical asymptote is going to be at negative 2. So let's go ahead and draw it. Remember the t, we're going to do it at the end. And those are my test points. Then we're looking at the end behavior. Now, if you notice, both of them have an x to the first power as the highest degree. Because that's the case, then we look at its coefficients. And we get 1 divided by 1, which is equal to 1. So that's where my horizontal asymptote will be, at y is equal to 1. Then my y-intercept. For my y-intercept, we look for where we set x equal to 0. My equation, I've got 0 minus 3 over 0 plus 2 plus 2. We simplify it, negative 3 over 2, which is negative 1.5. And we want to put these as a decimal so we can easily graph it. So my y-asymptote, I'm sorry, my y-intercept is at negative 1.5. So now we want to look for more points. Again, we look at the vertical asymptote. We're going to look for 2 points or 2x values to the right. We already have the 0, so we really just need the negative 1. So we're going to use a test point at negative 1. Now, there's really not enough room up here, so I'm going to do it up here. So we're going to do where x is equal to negative 1. And then, so we're going to put negative 1 for x, negative 1. So we're going to subtract 3 and add 2 to negative 1. And we get negative 4 over 1. So this point is at negative 1, comma, negative 4. Negative 4. So where x is negative 1, my y value is negative 4. Now that looks like we can graph it now. We can see that these are going to connect and then they're going to get super close to that asymptote, and the same thing with this direction. Now let's find another test point. Let's look at negative 3 and negative 4, see what that gives us. So we're going to do another test point. Let's find some room right here where x is equal to negative 3. So we've got negative 3, and then we're going to subtract 3 and add 2, because remember, we're following this equation. And then we've got negative 6 over negative 1, which gives us a positive 6. So at negative 3, my y is positive 6. So we've got this point right here. Okay, let's do negative 4. I'll do another one here. X is equal to negative 4. Or and negative 4. And then we're going to subtract 3 and add 2. negative 7 over negative 2. And negative 7 divided by negative 2 is a positive 3.5. So negative 4 comma 3.5 will be my next point. And to me, that just does not give me enough points to do a nice curve. So I'm going to do another test point at negative 5. Let's see if it fits. So x equals negative 5. So we've got negative 5, and then we're going to subtract 3 in the numerator and add 2 in the denominator. That gives us negative 8 over negative 3. That's approximately 2.6. So this point will be negative 5 and then positive 2.6, which is about over here. So from here we have enough points to go ahead and graph it where we get close to the asymptote, but no. And to find the domain and the range, again, we look at all real numbers except where my asymptote is on the x. And because we don't have any holes, we don't have to worry about anything additional. And then your range is all real numbers except when y is equal to 1. All right, and then we're going to go ahead and do example number 4. Go ahead and do it on your own and see if you can get it. Make sure you hit pause and come back when you're done. All right, so hopefully you are done. Let's go ahead and go over it. It doesn't need to be simplified, so therefore there are no holes. Now let's find the roots. We set the numerator equal to 0, and negative 1 is not equal to 0, so there are no roots. Your asymptotes, we set the denominator equal to 0, and we divide by 2, x is equal to 0, so my asymptote is at x is equal to 0. Our test points, we do them at the end, but let's look at the end behavior. Again, there's only an x in the denominator. Therefore, the x in the numerator has an exponent of 0. So this is bottom heavy, which means my horizontal asymptote, y is equal to 0. We're going to do the end behavior. Okay, we're going to do, remember our test point, we're going to do it at the end. We're going to look at the end behavior. And for this one, we have another one where there's only an x in the denominator. Your x in the denominator has an exponent of 1 because there's no x in the numerator. That means it has an exponent of 0. So this indeed is bottom heavy. And because it's bottom heavy, then my horizontal asymptote is that y is equal to 0. So let's go ahead and sketch that on the graph. And then we look for our y-intercept by setting the x equal to 0. So we've got our original equation is negative 1 over 2x and negative 1 over 2 times 0, negative 1 over 0, which means it's undefined. And it's undefined because of that asymptote that is there. So now let's find some test points. Let's look for 2 points to the right and 2 points on the left. So because we didn't use this space, I'm going to go ahead and use it for my test points. We've got x is negative 2, x is negative 1. So negative 1 over 2 times negative 2. And then negative 1 over 2 times negative 1. Over here, we've got negative 1 over negative 4, which is negative 2. And then this ends up being a positive 1/4, which is positive 0.25. And then for this next one, we've got -1, and 2 times -1 is -2. My x is -1. These turn to positive, so that's a positive 0.5. So let's go ahead and graph those two. We've got -2 and positive 0.25, which is about here, and then -1 and 0.5, which is about here. So with this one, we can more or less see that my graph is going to go super close this way, and this one's extremely close going in this direction as well. And now we're going to test positive 1 and positive 2. So x equals positive 1 and x equals positive 2. We've got -1 over 2 times positive 1. It's -1 over 2. So we've got 1 comma negative 0.5. And over here we have -1 over 2 times positive 2. That gives us -1 over 4. And that is 2 comma negative 0.25. So we've got 1 negative 0.5 and then 2 negative 0.25. So again, now we have enough points to see that it's going to be super close to that asymptote already. And that's what my graph looks like. So now let's look at the domain and range. Remember, for your domain, it's all real numbers except where the vertical asymptote is, which is at 0. And there are no holes, so we don't have to worry about anything else. And then for the range, again, it's all real numbers except we have our horizontal asymptote. All right. Have fun with your assignment.